while everything's coming over, we have a very important guest speaker who's going to be coming to talk to us next week. I think she's a wonderful person. She is Lorena Messa, and she's going to be coming to talk to us on November 17th. This is a Zoom conference. And also on the 19th of November. On the 17th, it's 6 p.m. to 7 p.m., and the 19th is going to be 12:30 to 1:30 p.m. She is part of the Mozilla Ethics grant that we have. We are bringing her in to talk about, asking her to share some of her experiences in working in ethics and responsibility in technology. And so, in other words, she is a GitHub executive, or is it a GitHub? She's a GitHub activist, and she's also a Python activist, and so she's very important in those two areas. And so she's going to be coming to talk to us about developing code and developing technology with an ethical and responsible point of being. And so I do ask you to come to this thing. I will be giving you an extra credit type of, maybe I haven't decided exactly what that is, but on the day you'll know. But if you come, you'll know what it is, and then you can have some extra credit from listening. But I'm hoping that it's not just the extra credit which will entice you to come and listen to such a remarkable speaker. Rather, I'm hoping that you'll come because her message is actually a very important message that we should all pay very close attention to. And that is that when you're creating technology, you also have to be responsible because that technology could be used in unusual ways. And we have to be kind of cognizant of some of these usages or these potential usages of this technology. And so she is going to be coming to talk to us. Zooming in, there is a RSVP. Please do use this RSVP. I will also send this flyer out on Slack today, later on, as soon as class is done, perhaps. But you'll have this poster there so that you can have a reminder. But please do add this to your calendar. I mean, this is actually a very important event. So anyway, I think she's a wonderful speaker. And she's with Python and GitHub, so cool. All right. When we have been working with Mongo, we have had to know, sort of like when we're doing queries for information, we have to know what that information that we're looking for is. In other words, we have to know that the information is there. And so we have to have an idea that there is something to find. And so we're looking through raw data, if you will. We're looking through like just throwing some information into a database. And we want to find some meaning from this data. And that's really where these queries are coming from. And so what we're doing is we're looking to see whether, for instance, what are all the people who work in a specific department, or what was the kind of sandwich that all the people in geology had for our picnic. It's like we're actually looking for specifics in that data set. So we know that information is there somewhere. So we're looking for meaning in that data. But now imagine, for instance, that you have a database that looks like this, where you have just all this stuff just all over the place. And it's like numbers, and numbers by themselves are not readily available, I claim, to the human eye, which means that when you first see these numbers, it's like it doesn't click that there's a trend going on. And so sometimes you have to do some analysis, and that's like plotting and some other types of things to figure out really what your numbers are saying. But again, you're looking for something. You have to, I would say, you have to have a kind of an idea about what it is that you're looking for. So you've just collected some data, you're storing it in this database, and then you put this data into an SQL table, and now you have to write some kind of a query to find something intelligent in this set, like maybe some kind of some kind of trend or something you're looking for. But again, this is becoming the kind of the foggy zone, I call it, because it's like you don't really know whether this thing that you're looking for exists, or in many cases you don't even know what it's called. It's like you don't even know that it's there. And so looking at all these are genes here, and I'm looking at these genes, I'm looking at expression values. Maybe I don't know that certain genes have certain types of expressions, and so I'm kind of stuck. And so I don't know where to begin my queries. And so the reason why I'm talking about queries is because the queries, when you're working with databases, really a query is just to explore a relationship. It's just a relationship. We've been talking about relationships. I mean, this sounds like it's some kind of love phones or something, like some kind of love class where we're talking about relationships, but not those kinds of relationships. We're talking about relationships between data. where you have two different attributes, or three or four, or some arbitrary number of attributes, but they have some kind of relationship. And that relationship, when you discover it, is the piece that you're looking for. But remember, to find that relationship, that's about a query. You have to write a query to make that relationship be found. So getting back to this data, you might think, okay, well, fine, I'll start looking for a relationship in this data. I don't know what it's going to look like. I guess my genes are going to have some kind of ENS num. Not sure what that means. That's actually a primary ID for those genes. They call them ensemble numbers or ensemble IDs. But anyway, supposing you don't know that. And then I have this column, which is the X005, and I have an X7D, and I have an X93. Okay, so those are my expressions. So I guess I should write a query that's going to try and help me find some kind of information in this. And so you might begin your queries by the stuff that we see in the red there, where you have select human gene where n some like E percentage sign, which is again looking for this is your gene, or that's your kind of your regular expression, if you will, where you're looking for everything that begins with an E. And so then you run that query. Nothing too incredible comes up, because all of these things in the ensemble number column, or the second column, begin with E. So again, you're not going to discover any amazing patterns there, because it's already clearly available. So then you might change things around a bit, where you do, okay, select human gene where, and then you have this number here, like 16s, or anything that begins with a 16 will then show up. That's okay, but what I'm saying is, like down here, you're beginning to run out of ideas. In fact, on the third query, you're already thinking about lunch, and then you're selecting a soup and a salad. And so what I'm saying is, it's sometimes very difficult to know what kinds of queries that you're actually trying to type in, so you can find a pattern. You're looking for a pattern, after all. And so you have to have an idea that that pattern exists. And this is like the main kind of the stairs to discovery, as I call them, in our class, where we basically began with data. We put together a schema. We ran a query, which helped us to find some relationships. Those relationships led us to knowledge, and then that knowledge we were able to kind of think again and come up with some kind of conclusions about that knowledge, which then led us to ideas and further discovery. That's really how it works. But remember that it all starts with this SQL schema and queries area, where you have to have an idea about what that data has in store for you. Otherwise, you're not going to find any relationships. You don't know that those relationships exist until you actually put them on in your schema and you write a query that uses them. So the stuff, what I'm saying is that our discovery when you're using databases is often stumped in many, many ways because you don't know what those relationships are that you're actually trying to go after. And that becomes a major, major problem here. So we ask ourselves, is there a way to find relationships in our data sets without first knowing that they exist? In other words, can we find some kind of relationship without having to type in a specific query where we have an idea that that relationship already exists? If I don't know that the relationship exists, can I still write a query kind of arbitrarily to find the relationship? Well, it turns out that we can, which is actually a really exciting thing. This is our new database that we're going into. This is called Neo4j. Neo4j is what they call a visual database system. And by visual, it's going to look really, really much different from how we've been using databases before, but I think you'll find this is actually kind of refreshing. In other words, when you look at how data is kind of connected, it's connected by a relationship. And in our SQL, that relationship was in the table, and we didn't actually see that relationship visually in the table. But now we will. And so what Neo4j allows us to do is just to pour in a whole bunch of data, and then relationships are placed, and that's where the edges come from. We do have to have an idea about what those relationships are. We do have to figure out how we can connect one node to another. But the nodes themselves are actually the data points. And the idea is that once you have connected one node to another, it becomes kind of like a social network in Facebook, where you can see how this node on the far left is connected in some way to the node on the far right. That represents a relationship. So you can say, oh, this is interesting. I can see that there is a connection in my data between this node all the way over here and this node on the other side over here. and I didn't have to run a single query to find it. I can just see it. And so that's where Neo4j comes in. And so our relationships are going to look like this, where you have a whole series of nodes, and each node, in this case, I just put node, but each node in this case could mean something like, names of people. These are all relationships here. Let's say that Mary knows Mark, who knows Thelma, who knows Shaggy, who knows Scooby, and then we have the, I don't know, something else on the, some other node that's on the outskirts on the right here, who hasn't been connected to the network yet because they don't know anybody just yet. And so you can kind of get an idea that I could start at Mary, which is the node on the far left-hand side, and I could say with some certainty that Mary doesn't know the node which is standing by itself, or that she has no way of reaching that person through her social network because nobody knows that person. So what I'm trying to say is that we've just made that, that is a relationship, that's a discovery. We've just made that relationship and discovery without having to type in a single query. Just by looking at this graph, we're able to see that nobody knows that node which is hanging out on the right-hand side. And so if this was like some kind of, if this is a network of maybe business partners or something, you might say this business partner on the right-hand side, this single node of this disconnected graph, isn't involved in the project. We need to find a way of involving that person or that group into our project, and then that would be how you could see that they're not, that they haven't been connected, and that actions need to be done. And so you have the wisdom that follows from how do I add this person to my group so that they can be involved. So, but anyway, we have these nodes and edges, and so the big blue things are the nodes, and the edges represent how this node is connected to another node. Now you can change these edges, these connections, if you will, any way you want. These are these relationships. You can define the type of graph that we're looking at, and this is what they call a graph from graph theory. But you can actually define the kind of graph any way you want, where you can say that this is the relationship, or this is the node, or this is the this is how I'm going to work with this is how I want to study these these nodes. So we can create as many relationships as we like between nodes. The relationships are really describing the types of connections, like how one node is connected to something else. You can have a relationship as arbitrary as likes peanut butter sandwiches. It's as basic as that. But you can see that you can see that there are what they call single nodes, which is like this node that's on the far right. You can see that if those nodes are there, that means that they're not connected to the graph. That means that they don't share the relationship in some way that you're trying to explore. And so then you can take action. If that's a problem, you can take action and bring those nodes into the graph in some way by inviting those people or making some decisions so that becomes a part of your network. But what I'm saying here is that when you look at these types of graphs, it's much easier, I would say, to infer how the relationships between nodes and how things interact with each other, how things are related to each other. It is much easier to make those inferences when you have a visual canvas to work with, rather than when you have to type in a query and say, okay, is this node connected to the rest of my database? So here we have node A, B, and a car. So you can see that the relationships are actually quite extensive here. So you can see that person A is married to person B. Person A lives with person B. And so married to and lives with, these are the types of relationships which I'm exploring. Okay, this relationship exists here. Now, one thing that I can discover here, and I don't have to even type in a query to find this out, is that person A drives the car that person B owns. That's interesting. And so it seems that person A, I can see that this person is married to but lives with, but I can also get this other piece of wisdom, which is that I know that this person is driving a car that is owned by somebody else. But imagine, for instance, that if you have like a network like this where you have a whole bunch of different pieces of information, you can just look at the information and get an idea about how everything is connected. Of course, in this, and this is a computer science tool, and so we're not just looking at all this stuff here. We actually do have algorithms that will actually crawl from node to node, checking for different types of relationships. But visually, though, you can just check it. You can just look at these things and see that the relationships are there to explore. This is what the network is going to look like. This is actually kind of interesting here. This is a company. I found this online somewhere. But this is a company, and you can see, for instance, all the names of the people who are connected to this company. You can see who the chairmen are from different companies. I think all the violet nodes are all the chairmen from different companies, and then you can see who they're all talking to. It seems that they all have one person there. There's one arrow that goes from the pink or the rose, or sorry, the pink or the purplish nodes that points to an orangey colored node. And so you can see, for instance, who the chairman's, I guess, point of contact would be. But here it's like I don't have to even write a query to see who's talking to who. I can just go ahead and look at this thing and say, aha, I can see that something's going on. Anyway, I think you kind of get the idea. I think that maybe, well, here's another one that's even more exhaustive. You can see these points get actually these graphs get quite big quickly. Now you can use the software to trim down the number of nodes that you see and do all kinds of things. You can kind of get a better visual. But what I'm trying to say, though, is that because you can see these two arrows here, because they're connected in some way. Now, the actual connection we have to study, but that is a relationship. And so I can see, for instance, that here, I can't really read this, but I can see that the node with the arrow, the gray node on the left, is in some way connected to the node of the arrow on the right. I'll say that again. We can actually see that they are connected in some way. There's a relationship which brings those two nodes together in some way. Now, the relationship is not direct. It's what they call an indirect relationship, where you can see that one thing is connected to another, not directly, but through a series of other nodes. But that is itself actually a very important discovery, because imagine that this is some kind of a, I don't know, a social network where you're trying to figure out who knows who. Well, you can say that if I'm trying to build a social network where I can get from the left-hand arrow, and I can find a network of friends so I can get to the right-hand arrow, just by going through people, then you can do that. You can find out who those people are just by looking at this. And so I can choose any node that's talking to the left-hand gray node and make my way from node to node to node all the way to the right-hand side. So I wanted to spend the rest of the class really kind of just getting the software going. You'll see that there's some software that's you've downloaded, actually some script files that you've downloaded. I'm hoping that this thing works. I was able to test this somewhat, but it may have some trouble still if you're a Windows user. I remind you that I'm not a user of Windows, and so it's sometimes difficult for me to check how everything's going. But I will run on my end the Mac version of this thing. And what's going to happen is that when you run this program, it is going to install a Docker container which contains your Neo4j installation. So I'm scared, but let's just give it a shot and see what happens. let me just go back. So how do I get back to my? Come with me, if you will, to my terminal. And of course, my terminal isn't showing up just yet. Let me just start this terminal. Where are you? Right here. There. Come. Now I'm here. So I have in my files here. I have actually you have just the two files. You don't have this other file here. That's something else. But you have this file here and you have this file here. And so the Windows file. So I'm going to go ahead and just run my. And I think that I may already have this thing running on my computer, so maybe you won't get the same results that I get. But if I type in sh, I mean, remember, follow the slides, everybody. I spent a good amount of time making these slides work, and so if you have any trouble, go back to the slides. But if you go here, you just type this command in here. Having my thing here. Now, this is saying I think that my container is already running. We can work with that error in a second here, but that's probably because I ran this thing last night, and then again I ran it. Then I'm trying to run it now, and it doesn't always pick up. But let me just check whether it is running. So if I go back to my my thing, my browser, there we go. It is running. And so the thing is that getting back to my error message, I'm getting this error message because it's trying to rebuild a container which is already starting. That's just part of the code. You can see, for instance, if I just do a search, or I show what's inside this, I can just take you through this. What it's doing, for instance, is inside the code itself. This is a batch script in Linux. But I made a similar batch script, although not as colorful, in Windows, which should work. I hope it works. You have some print statements here, but actually what it's doing to actually start this container is it's running this line of code there. That is your Docker code. Now, the reason why I put this into a file like this, not just put this into the slides where you just go ahead and paste this thing into your thing, is because the lines make it difficult to just to run. So, for instance, if I copy this and I dump this into my terminal, it's not going to work because each of these things is its own special line, and then the terminal doesn't like running things like that. It gets confused. It thinks that these are actually not one command, but like maybe 8 different commands, 9 different commands. And so that doesn't work. And so you really have to have this thing into a giant file. Although what you could do, if you don't like using this file, if you remove these marks here, these slashes at the end of each line, if you remove those lines, or those slashes, and then you put everything onto one line, so it's just one giant line of text that just goes right through one huge command. All of this is on one line with the omission of these, then it should work. But I couldn't put that onto my slides because it's one giant line and I couldn't break it up. And so I thought that maybe putting it in here is one of the best ways. Okay, so now this is going to actually download all the Docker stuff, and hopefully everyone at home, you have you've run the thing and it's downloading. Hopefully it is. I mean, let me know if it doesn't. I'll have some other ideas. But hopefully that's happening. And what it's going to do is it's going to actually create a container which is going to be called test Neo4j. That's the name. That means that when you are actually running or when you're starting or stopping this container, you have to refer to this container as test Neo4j. This actually comes right out of this place right here. I went to the Neo4j website and I found their code to put this together. And so this is your reference. And so if you have any trouble or if you'd like to further configure this to do something else on your machine, then don't ask me this yet. Go to the website and ask them first and see what they. I mean, they have an extensive documentation there that has all kinds of answers. So, for instance, if you wanted to run Neo4j not in a Docker container but on your local machine, you can still do that too. Just go to again neo4j.com and see all about it. Anyhow. The actual command that begins our container, though, is this command down here. And on Windows, it's just docker start test Neo4j. Again, that Neo4j is the name of the container. But you have to actually start test Neo4j. You have to start the test Neo4j. You actually have to begin the server. And what the server is going to do is then open up your ability to do the networking and to check things and to run queries. In your browser, and so that's really where this is all coming from. But you have to start that server up, and this is the command to actually make that start. Now, as you can guess, if I'm starting my container here, then I can end my container here. Let me just get back to something here. When you have started this container, it's going to look a lot like this. Let me just you're probably still downloading your containers now. Let me just get back to the slides for a second. We will go through this in just a moment. But I wanted to take you through some other stuff. On your slides, if I can get to this, there you are. On your slides here, these are the commands you could use that actually kind of build the container. Each thing actually does run the container at the end there, so you still might get an error message when it's trying to build a container that's already running. That's where that error message comes from. But you can always just type in this command at your command line, docker start, if you're using Windows, or you could use sudo docker start and test Neo4j if you're using Mac and Linux. Now, one thing I've received, I think probably 5 emails over the last week or so about Mongo and about how to stop a container if I'm having some trouble. If I'm trying to build my container and it's not working, what do? These are actually the same slides that you had from Mongo, and I'll go through them again just because I believe that they're necessary. But if you type in docker ps, it will tell you a container ID. If you only have one container running, then it will tell you that one container. And in this case, I'm thinking that container is going to be your Neo4j container. So for instance, here, if I type in docker ps, actually I still have my Mongo container running, but I have the test Neo4j container running, and I can see that the container ID is this number over here. You want to copy that container name, copy that, and make sure that you have that in memory. Because the next thing you're going to do, if you go back to the slides, is you're going to be stopping that test Neo4j container. You have to stop that container. and then you have to remove it so that you can build it again without errors. It's just one of the ways that it's just one of the things that happens with Docker, but that's okay. There must be other workarounds for this, but this is the one that I use. If you find a better way, please let me know. But what I had to do though is that because I found the container, and by the way, your container name is going to be different. It's not going to be the same. This is the container on my machine, but everyone's machine is different, and so they're going to have different container IDs. Anyway, but on my machine though, I found this container ID, which is the 662 number, and then I had to stop my Docker test Neo4j container, and then I had to remove that container by typing in docker rm, and this number is exactly the same container ID that I got earlier. If I'm using Linux or Mac, then it's this command here, but it's essentially the same thing. I'm just putting sudo in front of it. So now, if you have run these commands here, your container should be gone. And in fact, if you go back to the, I'm not going to do this because I want to stop it, but if I type in docker and I type in ps again, then you should see that your container is no longer running. Of course, it is here because I haven't done anything. But if these steps have gone according to plan, then the container should be stopped. And then in which case, once that happens, once you've stopped your container, then you can go back and you can run these commands here to rebuild and then start the container. Or maybe, for instance, in fact, you can try this first. Just try typing docker start. Actually, no, that won't work. You still have to run it. If the container is removed, you have to run it again. And so you'll have to use these commands here. But these commands, though, do work. And so it's for that reason that I'm saying that once you have run this command, and the container is running in your computer, I claim just let it run until the end of the class, or until the end of this chapter in our class, and then you can kill the container after that. And it's for that reason that I continue to use the Mongo container here, just so that I don't have to keep going back to these killing a Docker container slides, so that it just takes a lot of extra time. But I'm thinking though that if you remember these slides, then if you have that trouble where you can't run the container because it's saying that there's another container with the same name or some strange error message which isn't really quite understood, then just try stopping the container, removing the container, and then rebuilding it. But when you rebuild it, it's not like you have to spend a whole bunch of time online doing that, because you will already have all the code, all the stuff downloaded already. With your permission, I'm going to go now into actually using Neo4j just to get things started. I'm hoping though that that most of you, if not all of you, have already been able to run the program, and you've seen that your Docker container is being built and everything's okay. Do you see that in here? Is your container coming? Oh. We're having some connection problems. Yeah, I don't know anything about how to work with connections to the internet. I think that if you just I think that if you're trying to connect to the internet, you're having a connection problem. If you go into airplane mode on your laptop and then you go back, in other words, you turn off the Wi-Fi and then you turn it back on, sometimes that makes a difference. I know that sounds really ad hoc, but that's what I try first. It's kind of like rebooting Windows if you're having after you've installed something, and sometimes the system becomes really kind of unstable, so you have to reboot. But I think that if your internet connection becomes unstable, sometimes you can do the same thing. Let me know. Okay. Anyway, but still, I'm going to move on if I can. So when you first get to your browser here, what you want to do is you want to go to localhost, and hopefully you can all see where I am. Yes. Localhost :7474. In fact, I've made a note of all of this stuff. If you're running my special, colorful, handy-dandy, super cool program on the Mac side of things, it's in this program here. All this green text is stuff that you need to know. But this is your browser that you're supposed to go to, and here's the login and password that you'll be using. Now, the login and password is also listed on our slides, which I'll show you is, where are those slides? I keep losing them. Here we go. So if you go back to the slides here, you'll find that I put the user and password right down here. So if you type in, actually, is it test J? No, sorry, it's not test J. It's just test. I need to change that. That's not true. That's not true. That's not true. It's not test J. It's test. Go back to this. It's just test. I made a mistake. Sorry, guys. I have to fix that. But anyway, come with me if you will. Let's go back to the. Let's go back here and just log into this thing and see what we can see. So when you go to this server, you'll see localhost :7474 browser. I type in Neo4j. My password is test, not test J, but test. You hit connect, and if everything has gone according to plan, you should find yourself here, which is refreshing to be in. If you find yourself here, that means that everything has kind of come together and it's kind of things are working as they should. Now, the first thing we need to do is I thought we'd just spend some time just playing with we'll just play with one of these things and see one of the built-in databases that they offer us. And so what we're going to do is we're going to go back to the slides, if you will, and type in this command. If all is well, you'll find yourself here. But there's this command here called play movie graph. So come with me and let's try this. And you type this in at the very, very top here. You can see it right in the you can see that in the graphic there at the top. But you have to type in colon play movie graph. Now, I am hoping that everybody got here. If you haven't, it's not a big thing, because it could be that it just takes some time to actually run the server on your machine. It does take some time. When you first run, when you actually start the container, it does sometimes take some time to actually get the server going. But all of this all this information that I'm covering now is in the slides, and so if it doesn't work today, please stay with it and go back to the slides and see what you can do. Now, don't click on any of these buttons down here. If you're looking at the if you're seeing where I am, don't click on this here, but rather click on the arrow that's on the right-hand side, so everything kind of moves over. Everyone see where I was? There's an arrow on the. If you follow my cursor here and you keep on going all the way to the right, there's this arrow. Click on that, and this will take you to this data set. And so this is built-in data that Neo4j actually gives us to play. So what you want to do first of all is you want to click on the data set, and when you click on the data set, you're going to see all this stuff has been copied and pasted into your command line field. I'm not really sure what they call it, but I call it the command line field. And that is this place right here where I'm working. All this stuff right here, this is the data which is being copied into Neo4j. Now, this data actually concerns, I think, a good chunk of movies which came out recently, between like maybe 1995 and 90, well, maybe more recently than that. Maybe it's actually up until almost present day. But these were all these old movies, and actually even before then. And actually, that's great. Anyway, well, this information, that was all information about movies. And so if you go ahead and push this button here, you see where I'm clicking? Maybe you can't. If you go to the tagline here, see that where I am right there? You can't see it because my face is actually covering it in the screen. But there's this little kind of a triangular shaped blue button. Click on that, and that will then send everything into your Neo4j server. In other words, that compiles a network of the data that you're working with. Now, this data is all movies, actors, writers, developers, seemingly all kinds of different things, directors, all kinds of different pieces of actually making movies. And so you can just kind of move things around and you can kind of see how actors and directors and writers, how they're all connected to each other. So for instance, this is something I didn't know, that Robert Zemeckis, right here, this guy, I'm just looking at this thing here, I didn't know that he had directed Castaway and The Polar Express, two movies which are exactly the same, not. So it's interesting to see that you can just kind of come up with these discoveries. Here's Ron Howard. I didn't know that he had developed, or had directed rather, Apollo 13 and The Da Vinci Code. He worked with Tom Hanks, I believe. And you can see that Tom Hanks is at the center of this network. In fact, if you, how can I get out of here? There's a way of doing this. Anyway, but you can kind of click around and see things. If you right-click on these nodes, You can get to this, hopefully you can see right now. You can click on some things where you have some, this little eye that I'm looking at right now freezes the node so I can move things around, but this stays put, I believe, or something like that. Or maybe no, it sends it away. It hides it so you don't see it anymore. I'm not going to do that. This little padlock actually freezes the node so it doesn't move around, but I think that this other node down here will then give me more nodes that's available for this actor who is Tom Hanks. So now you can just see this. You can just see this graph, and I haven't had to type in one query to know that Tom Hanks was in the Charlie Wilson's War, The Green Mile, A League of Their Own, Castaway, Polar Express, Joe versus the Volcano. Oh my God, it's an ancient movie. That was a renter when I was in school. Cool. I'll have to go back and check that out. That was pretty funny. Cloud Atlas, Sleepless, You've Got Mail, That Thing You Do. It's like you have all these different movies, Da Vinci Code and Apollo 13, all these different movies that Tom Hanks has been in, and you don't have to type in one single query. But the discovery comes here in that I can see that Tom Hanks starred in a movie, Castaway. Tom Hanks was in Castaway, which was developed by this guy here. Or I can see that Tom Hanks was in this movie, The Da Vinci Code, which was developed by Ron Howard. And so, for instance, I can now just find this relationship without having to write a query. I mean, if you think about it, how would you do something similar in SQL? I'd have to say select all movies from the movie table where Tom Hanks equals or actor equals Tom Hanks and director equals I don't know, Robert Zemeckis and some other. I'd have to type all this stuff in. And then maybe after all that typing, it works, and maybe I find something new, or maybe I don't. But here, it's all visual, and I don't have to worry about anything. One thing I'd like to show you, though, is if you miss tables, you can still click on the table button right here, and you can still see that all of your data is in this, you guessed it, it's in a big JSON file. And so if you wanted to, you could always copy this out and put this into your Mongo. And so now if you miss Mongo, you can still do that. It's quite cool. If you want to also, you can click on this text. If you still miss SQL, you can take this information from this table and put it into SQL, and so it's all right there. And so it's like you have all this information in different formats. Now you can type in some code here. You can actually see what this code looks like for Neo4j. Of course, all the code is just all mixed together. Don't worry about the code just yet. I think that on Monday and on Wednesday, we'll spend some time actually talking about what the code is doing. Like, what is all this stuff going, what's the syntax, what's happening here. So don't worry about that just yet. But for now, though, just concentrate on the fact that you can actually use a perfectly working and quite cool graph. Now, let's go back to the slides for a second, see if you can see, just to see what else we can do with this. You can drag things around. There are some interesting things you can type in to kind of get an idea about how your network is created. So here, for instance, this is a command, call db.schema.visualization. Let's say that I want to know what are all the relationships that I have in my Neo4j. Like, what can I do with this? So I go up to if you can see where I am here, I'm at the top. I just paste this in, call schema, db schema visualization, press enter, and then I get this really cool little graph, which is not the data, but rather it's a graph to show me that I have the acted in. This is one of the relationships which is defined in my data. Acted in, reviewed, produced, wrote, directed, and follows. And so now you can get an idea about what is actually, what the relationships are that you can study. Now, you're probably asking yourself now, if these relationships are there, I guess I have to know that there's a relationship of that nature to program into my database to begin with. And you do have to put those relationships in there. So you do have to have some idea about what the relationship is that you're looking to study from the very inception of your or I guess the conception of your database. In other words, your data has to be somehow put together in such a way that you actually have information about how the acting is, or acted in, reviewed, produced, wrote, and directed. In other words, you have to have that information inside your database. But once it's there, you might find that someone was acting in a movie which was directed by somebody else, who was written by someone else, who was also starring in a movie who was directed by such and such. And so that is the relationship. This person is related to that person, this person, and this person, and this person. You can see a whole string of how everyone is kind of connected. When I first was spending some time talking about Mongo in one of these classes, one of my students was a theater major, and she said it's actually kind of interesting that we have this MongoDB now, because one of the things that she wanted to do was to go to to go to New York and to be on Broadway, and to be doing all kinds of like performances on Broadway. And she said that it was interesting to have Neo4j because now she can create a network if she can find all the names and the time, a network of all the people who are involved in Broadway productions, so that you can see, for instance, who she should be talking to in order to find out about roles which are coming up in new movies. So in other words, it's like you can use this to kind of socially network and create strategies about how you should, who you should plan to talk to get into certain types of movies or plays. Anyhow, so there is that. This is a good website if you want to check this out. This is just more kind of interesting things you can do with this. Here is another good command that you'll probably end up using at some point. This is like, what are the node types? And so, for instance, like what are the node types? What kinds of information do they contain? Well, for instance, you have in your node, you have the type, you have the label, you have the property name, and you have the property types, and if it's mandatory. We'll talk about most of these things next time. But really, though, these are pieces of information you'd use when you're actually going to be kind of coding your node. When you're giving it information or describing relationships, you can, or naming the node here, you can actually work with this as your code. You'll see what I mean next week, I think, when we get to these. Another thing that's actually kind of interesting here is, what are the relationship types? In other words, you're probably asking yourself, well, is there another way of finding out how all this stuff is related? Yes, there is. Type in here, and this what we see here is exactly the same piece of information that we see here. This is just a visual version of the same thing. We've acted in, reviewed, produced. Here we have acted in, directed, produced, wrote, follows, reviewed. Now, one thing that I will say is that this is becoming kind of full. I'm getting a lot of stuff that's showing up in my window. You can click on this X right here to close some of these panels down so that you have more space. And I would recommend doing so, because when you're working with really big graphs, after a while, I think you'll find that that your memory kind of begins to run out. And so you might want to consider going through and actually clicking X just to close down some of these panels which are there. One more thing I'll talk about, though, which is actually kind of interesting. There's some other commands that you should try too, just to see what they do. You can type in this command here, match. This is when you're doing in SQL, when we did a query, we had to type in select. Well, here we have to type in something called match. What this is going to do is this is going to make another map of us, another map for us, where, for instance, now you can see, I think I just pushed down 2 buttons, I can move things around, there we go. I can see, for instance, reviewed. Who are the reviewers for some of the prominent movies that I have here? And so here I have Jessica Thompson, perhaps? Jessica Thompson was a reviewer for, just from The Replacements, Jerry Maguire, Unforgiven, Cloud Atlas, The Birdcage, and Da Vinci Code. I can see the movies that she reviewed. And again, I just had to type in one basic query to get that notion. Jessica Thompson also did some other, this is I guess some other data that she found, which is in the database. I'm not exactly sure why we're seeing two different. Oh, we're seeing two different things here because this graph over here is a different arrangement. Here we have, for instance, she was working with, or she's following a reviewer, Angela Scoop, and here now she's also following Angela Scoop, and she has James Thompson. And so, for instance, this is a different arrangement, this is a different type of relationship that we could also study. And so if you look around somewhere, you'll find a whole bunch of other types of relationships that Jessica Thompson was in. Now, we don't see everything here just because this is like the 20, we're just having 25 nodes that we're looking at. But if we didn't have that 25 node limit, like I can go up here perhaps, to see if I can do this, remove that and run this, and you should get a whole bunch of new stuff that just shows up. But the data, though, isn't exhaustive. It's just a sample set, so perhaps it's not all there. One thing you can click on is here. Perhaps you can see this. You can kind of shrink things down if you use these arrows. Or, sorry, if you use that, so the arrows where they're pointing away. You can make this thing kind of, you can zoom out. and then use the magnifying things to move in. And then when you're finished, you again go back here, and you click on that, and you're back to where you were working before. One last thing I'd like to say, though, I know that we're running out of time, and I do apologize for that, is when I was when I was doing my master's, my roommate spent they exhausted a lot of time playing this game called the Kevin Bacon game, where they're trying to figure out like how Kevin Bacon was related to a whole bunch of other movie stars and directors and people. Well, you can now play that same game, turns out, with Neo4j, where if you just type in this code here, what this thing does is it runs a query that shows you the networks in which Kevin Bacon is actually a prominent part. And so that means I can zoom out now, and I can see, for instance, all these different networks where Kevin Bacon played a profound role. And so he's somewhere in here. But these are all people who know Kevin Bacon in some way. And so all you have to do now is just find out what Kevin Bacon is. Let's just find out where he is. Kevin, where are you, man? I can't quite see it. Sometimes you can search and you just get the... he's in one of these nodes. Tom Hanks. So everyone sees it. Oh, here we are. It's right here. That's Kevin Bacon. I can take that, and what I can do is I'm going to freeze that node so that everyone else is kind of like going away, but Kevin Bacon is right in the middle. And so you can get an idea for these networks. You can see how Kevin Bacon is actually connected. And so that means you can play the Kevin Bacon game where you can see how many people apart from Kevin Bacon are you. And so you can see that, for instance, this person, Kevin Bacon knows, let's just say that he knows this person here, so maybe that's 1 degree. And then if this person knows anybody else, how do I do this? I guess I can't really, this isn't the best example. Like I said, Kevin Bacon knows this movie here. This movie was directed by this person, whatever that is, or acted in by this person, directed by this person, and so we have this person over here. So what I'm saying is, like, you can kind of get an idea about how things are connected. And again, the fascinating thing about this is that we only type in one simple query, and we have all this information to digest. And so you can really spend seemingly days, hours of each day just going through these networks and discovering all kinds of new stuff. Now, when you are finished working with this, I don't recommend stopping this just yet, but if you wanted to, you could do that. You could just type in stop Neo4j in Windows, or if you're working with Linux and Mac, you could stop your container this way, and that means that it's still working, or the container's still there, and you can start it again later when you want to get back to using it. But if you wanted to remove it, you can with these commands here, and that means that once you have removed the container, after you have stopped it, then you can rebuild it, going back to the commands in these files here. Okay, so I'll just go ahead and stop this. I guess I can see what happens if I stop it here. I'll show you so you can get an idea. But what I'm going to be doing is I'm going to be typing in sudo docker test Neo4j, and I have to type in stop. I'll put in my password, all this crazy stuff. And it's stopping my container. I'll just show you this. It's taking some time. Okay, so it should have stopped my container. If I type in docker ps, I can see that the container is now stopped. The only thing running now is Mongo. But also, though, more tellingly, if I go back to where I was working before and I hit refresh, you can see that my container now is not running because I'm not able to get to my Neo4j. Anyway, that's it. On Monday, we're going to talk about some other cool functions. We'll talk about the language itself that uses, or that that Neo4j uses, and we'll see what else we can do. Also, one thing I should tell you, please do keep in mind, is that we do have our tests coming. I'll go through the test. I'll have the test results coming out. Maybe next Monday or next Wednesday. But I'll send you a text though when you have these things coming up. I'll tell you a text when you can check your Sakai scores. But there are some Sakai scores that have been changed recently, which you can visit now if you want. But the actual scores themselves will be out soon enough. Please don't forget about visiting this talk. It's going to be just terrific. Anyway, everybody, stay well, be safe, mask up, and I'll see you on Monday.